working with rationalizing square roots. Right, so if you're looking at this, you look to simplify your radical. Root 5, there's no way to simplify it or to rewrite it. So we're then going to multiply the top and bottom by the same value. The same value is going to be based on the same index, so square root, the same base, 5. And you need the total number of these bases to be multiplied by each other to equal the index. In a square root, the index is 2, so you have 1 5 to begin with, so how many more do you need? Just the 1. So when you multiply across the top, you get root 5, and across the bottom, again, you've hit that nth root of a to the n is equal to a, so we just extract our base to get the 5. Okay, so that would be your answer for A. And for B, it's slightly different, although the terminology and rules are exactly the same when you're dealing with a cube root or anything beyond a square root. You look to reduce your denominator or your radical. There's nothing to reduce it, no way to rewrite it in a simpler form. So we're going to rationalize, multiply by the same index, so the cube root, the same base, 5. And then in order for you to cancel the radicals from the denominator, you need that 5 to be multiplied by itself a total number of times equal to the index, which was 3. So we had 1 5 to start with, so how many more 5s do we need? To get to 3, we need 2. So now we can multiply across the top, cube root of 5 squared, which is 25. And then in the bottom we have cube root of 5 cubed. Again, it fits this pattern where the index and power are the same, so they cancel, allowing you to extract just the base 5. So this would be the answer for B. And then finally for C, the first thing that you want to do here when you look to simplify the radical is, even though there's no perfect cube factors you can remove from 25, 25 does have an alternate form that involves a smaller, easier to work with base. So you do want to think of that in terms of that smaller base, 5 squared. And then you can look to rationalize, multiply by the cube root, same index, same base. We reduced it to a smaller, easier to work with base of 5. Now we need our base of 5 to be multiplied by itself, again, the same number of times as the index, which was 3. We had 2 to start with, so that leaves how many more? Just the 1. So now multiply across the top, cube root of 5. Multiply across the bottom, cube root of 5 cubed, which again fits this pattern. Extract the base as your solution. Okay. So that should be review, hopefully, from what we already talked about. Are there questions on rationalizing single-term denominators? All right. So if we look at problem D, you have your two terms in the denominator. One of them has a radical, so you have to simplify it. You'll do that by multiplying by the conjugate. The conjugate is same terms, root 5 and 3. Opposite sign between. There was a negative, you need to switch the sign. And then just multiply across. So leaving it as factors is the easiest, most efficient way to approach it. So just 2 times root 5 plus 3. And then in the denominator, we use our pattern. First term squared, so root 5 quantity squared. The root and the power cancel, leaving just the 5. Always a minus. And then 3 squared. 3 squared is 9. And so if you continue to simplify this, 5 minus 9 gives you a net negative 4. And so it's just a matter of canceling. 2 goes into 4 twice. So when you write your answers for this, be really careful, because when you write fractions, technically there's 3 different places you can put the negative sign in a fraction: numerator, denominator, and out front of the whole thing. Okay? Because the way that I have to enter these to be collected online, never put a negative in the denominator. Right? So for something like this, if you were entering this as your answer, what you would need to do, and again, what'll most likely happen is you'll see entries where there's something for the numerator and for the denominator. Move the negative up to the denominator, or up to the numerator, and you can either leave it as factors or distribute it through. So again, easiest thing would probably be just to leave it as a factor. So negative quantity root 5 plus 3 all over 2. That would probably be the ideal answer. If you felt like you wanted to distribute it through, you get a negative root 5 minus 3. Either of those are going to be accepted. Again, there's no reason to do extra steps if it leads to a potential for error or mistake. All right, and then the final problem, okay, as the one last thing and the kind of the problem that often causes the most confusion is when you have a number out front of your radical. So if you were looking to rationalize this denominator, okay, you're still going to use, again, the conjugate, same terms, 3 root 5 and 2. The same idea, you're using the opposite sign between them. It was a plus, so we change it to a negative. And then just multiply across. Leaving factors is, again, the ideal way to approach it. And in the denominator, you have to square the first term minus the square of the second term. If you square this first term, you need to think in terms of, or one of two ways. You either need to remember that you are squaring all factors of your product. So you square the 3 and you square the root 5. So what is 3 squared and root 5 squared? So you take 9 times 5, which is 45. So 3 root 5 quantity squared is 45. And now if you're somebody who forgets to square this first part of the number, which is a lot of you, right? Not just you, but in all my classes, what you may want to do, you can think of this in a different way. And that different way is, rather than have one part outside and one part inside, just move everything inside. So if you move the 3 back inside the radical, the square root of what number gives you a 3? 9. So if you take 9 and move it inside the radical, 5 times 9 is 45. So 3 root 45 really is the same thing as root 45. And when you square that, it just cancels the radical. So if this is tripping you up, just move the 3 inside as a factor of 9, and then simplify from there. But either way you do that, you should get 45 for your first term, always a minus, and then the second term squared. 2 squared is 4. And so then it's just a matter of simplifying what you have. 45 minus 4 is 41. There's no factors that cancel, and so you're left with this as your solution.